Hello everyone, I'm Jin Rumo. This is my final project presentation of EEL6562, Image Processing and Computer Vision. The name of my final project is Implementation and Evaluation of a Simple Image Noise Removal Tool. In this presentation, I will introduce 2 types of noise and 3 types of spatial filters, and the noise removal tool interface. And then I will conduct several experiments to illustrate this and compare the performances of the 3 types of spatial filters. At last, I will introduce 2 types of more advanced medium filter. First, let's look at the 2 very common noise. The first one is Gaussian noise. Gaussian noise can arise during the image transmission and acquisition. It can be reduced by using a spatial filter. The second one is salt and pepper noise. It can represent itself as randomly occurring white and black pixels. The white and black pixels is the reason why the impulse noise is also called salt and pepper noise. Salt and pepper noise creeps into image in situations where quick transitions happens. The 3 types of spatial filters we discuss here are averaging filter, Gaussian filter, and medium filter. The most intuitive one is averaging filter. The pixel values are replaced by the mean value in the sliding window. And the second type, Gaussian filter, is essentially a weighted averaging filter. The reason for the reason to assign different weights to different pixels in the window is that the pixels that are far away from the central pixels have less relevant, so they should carry less weights, and the decreasing of the weights obeys Gaussian distribution. The third type is medium filter. Each pixel is replaced by the median pixel value in the sliding window, and this can effectively remove low levels of salt and pepper noise without severely blurred edges. And on the other hand, the first 2 types of filters can blur the edges and small details. The goal of the final project is first to compare the performances of the 3 types of filters and analyze the performances by MSE, PSNR, and histograms. And finally, I will also show the implementation of one of the more advanced medium filter, the progressive switching medium filter. Here is the example of my noise removal tool interface. As we can see that on the left side, we can first import image, convert it into grayscale, and choose one of the noise, and we can set the parameters ourselves and apply corresponding noise onto the original image. And then we can choose one of the 3 types of spatial filters and set the parameters. And then we can see the resulting image on this area. And then I will illustrate this by conducting several experiments. First of all, we import an image and convert it into grayscale. For example, we first apply the salt and pepper noise to 20% of the image, 20% of the pixels in the image. We can see that MSE and PSNR values are automatically calculated and appear here. First, we try to apply the averaging filter with a 5x5 sliding window size. We can see that the black and white noisy pixels become gray, and this picture is more clear than the previous one. And as we enlarge the size of the sliding window, we can see that the gray area become lighter, and the whole picture becomes more smoother. But as we can see that the small details here and the edges here in the image are blurred. Then we try to apply the Gaussian filter with a 5x5 window and a standard deviation of 2. As we can see that the Gaussian filter gives a relatively similar result with the averaging filter. Then we try to apply medium filter with 5x5 window. Here we can see that the image become much more clear, and we can hardly see any white and black pixels as noise in this image. And moreover, we can see those small details and the edges are still there and they are preserved. This is a big advantage over the previous two types of filters. And moreover, we can see the MSE and the Pearson R values here. The MSE value is significantly smaller than the one of the noisy picture, and the Pearson R values is correspondingly larger than the previous one. It has almost 4 dB gain. And we can see the histogram of the 3 images. This one is the original grayscale image histogram. This one is the noisy pictures histogram. As we can see that the pixels are having intensity of 255 and 0 are significantly larger than the previous one. And this is the histogram of the filtered image. We can see that the filtered image's histogram is very similar than the original image's histogram, and the noisy pixels, like with 0 intensity, are almost removed according to the histogram. So we can see that the medium filter can very effectively remove the salt and the pepper noise from the image. And we can see we can import another image here and try to apply the Gaussian noise here. First we convert it into grayscale and apply Gaussian noise. This is the standard deviation of the Gaussian, and we can see the noisy image here. Similarly, we apply the 3 types of spatial filter respectively. As we can see that this image is much better than the noisy one, but the details and the edges are very blurred. So this type of filter can average out the black and white pixels, but can blur the image. Next, we try to apply the Gaussian filter. Here we can see that the black and white pixels are lighter. It's also they are also converted into more gray pixels. At last, we can apply medium filter. As we can see that the medium filter removing the Gaussian noise is less efficient than it removing the salt and pepper noise. And as we can see that the MSE value still significantly decreased comparing to the noisy image, and correspondingly the PSNR values is also larger than the previous one. It is 3 dB, almost 3 dB larger than the noisy image. Let's check the histogram. Here is the original grayscale image histogram. Here is the noisy signals histogram. Here is the filtered image histogram. As we can see that these two are relatively similar. However, the noisy pictures histogram is severely distorted, and the filtered one restored the image relatively effectively. Okay, let's come back to the slides.